Rewrite using rational exponents. Rewrite, you can replace the word rational by the word fractional. Rewrite using fractional exponents. So that says, what's the index on this radical? It's square root, so it is a 2. So that says it's 8, looks, it's x. The numerator of a fraction is 8. The denominator is 2. If I reduce this down, it's x to the what? 4th. Now remember when we were simplifying fractions on radicals that we were talking about taking the index divided into the power? So 2 divides 8 4 times, it was x to the 4th. This is why. Because if I have a power of 8 on the inside, the index is 2, the fractional exponent is 8 divided by 2. So when you're dealing with powers, you say, I want to simplify the radical. The numbers are going to be a pain in the rear. The powers are going to be easy, because then you can just divide the index into the exponent. And this is why, by the way. This says I've got x, the power is 2, the index is 8. So this is x to the 1/4. Now I can't really do anything more with it, because 1/4, that basically says this turned into a 4th root instead of an 8th root. It's going to be like big whoop. This would be, the exponent on 4 is 1, so this is 4 to the 1/4 power. Can't really do anything more with that. Well, I can't say that's not true, but we're not going to do anything more with that. You don't really want to know what else we could do with that. Not relevant to this class. Now, this is the power, by the way, of fractional exponents. The power of rewriting these radicals, which are symbols, into fractions, is that we have all the properties of exponents, because the exponents become numbers, which means I can add them, I can subtract the exponents, I can multiply the exponents. So you have the good old b to the m times b to the n is b to the m plus n. B to the m divided by b to the n is b to the m minus n. So if the bases are the same, you subtract. B to the m to the n power is b, you multiply the exponents. Here, of course, this is b, a to the 1, b to the 1. This is a to the n, b to the n. This is what helps us to simplify radicals. And of course, our non-favorite property is a to the minus n is 1 over a to the n. So all the properties of exponents apply. Now, so if I had 64 to the negative 1/3, 64 is being raised to the negative 1/3, so I'm going to put 64 in parentheses. What this says is it's 1 over whatever to the 1/3 power. And what's in that set of parentheses is 64. This is really 1 over, the index is 3. This is 64 to the 1 power. So that's really the cube root of 64. I don't deal with fractional exponents this way. I rewrite them as radicals if I need to simplify. And what's the cube root of 64? This is 1 over that set of parentheses to the 2/3 power. And what's in that set of parentheses is a negative 125.
What's happening to the exponent on the negative on the exponent?
Remember, we're using properties of exponents. A to the negative n is 1 over a to the n. So that negative 125 to the negative 2/3 is 1 over negative 125 to the 2/3 power. Now, this is what we did previously. I rooted first, cube root of negative 125, and then I'm going to power it. So this becomes 1 over, what's the cube root of negative 125? What is it? No. Cube root of negative 125. Negative 5. Now that's squared, so it's a negative 5 squared. Which is, what is negative 5, the quantity squared? Positive 25. There it is in all its detail, in all its glory. Now again, see, this is a set of parentheses. That's your power. I don't care what's in the set of parentheses because the power affects that whole set of parentheses. That's why when I look at this, it says it's 1 over, because it's a negative exponent, whatever that set of parentheses is to the 2/5 power. And now I care about what's in the parentheses. It's 32x to the 10th. So this becomes 1 over. Now I root it first, so it's going to be the 5th root of 32x to the 10th, and then I power it. Root then power, which is 1 over, remember this whole thing is going to be squared. The 5th root of 32 is 2, and the 5th root of x to the 10th is x squared. You remember 5 divides 10 twice. So 2 has a 1 on it. So this is 1 over, what's 2x squared squared?
4x to the 4th.
4x to the 4th. So 2x squared times 2x squared is 4x to the 4th.